Hey guys, I got something that might be a little bit interesting for you. It's the let's just switch this on. When you're using your drone, your Hubsan H501S, there's a selector in here, so you can go in here and you can change the frequency of your FPV, and you can also turn on and off the camera, the feed here that you see on the screen. Now I'm just going to put this back on for a second and go back out of this. We're going to boot up the drone and I'm going to show you what I mean. So first of all, as well, because a fellow YouTuber, Sonic Ox, asked about the current being drawn, idle current being drawn, and we're going to compare notes to see if that was anything to do with the heating issue, or the heating issue that I thought I had. And first of all, I was going to put a meter in line with it and do this, but I've got a power supply here. All this comes from my solar panel as well, so I like using this power. This comes from the solar panel, this comes from the solar panel, all this charging stuff comes from the solar panel. This is a solar panel, and this is a solar panel as well. So it's summertime and so I've got plenty of charge, so I'm intending on using that. So when I turn this on, at the minute it's set so we have a display here, so you're going to get to see the power that is used when we first boot up the drone. Okay, I've got it set. I'm going to actually set it to, I'm going to set it at 8.4 volts. It's set at 7.9 now at the minute, so let me just change that to 8.2, 8.3, 8.4 volts. Okay, and let's turn it on, and you're going to get to see the power, what it uses as it boots. Okay, some people may not find that interesting. I find that interesting. I like to know what's going on with these things. So now I'm going to calibrate this in. It might look like I'm going to get into a pickle, but I'm going to do this anyway. Okay, and I'm going to do it this way. Let's see if I can just turn this over, and hopefully it won't ask me to do this too many times. Okay, that's all good. We're done. Just set that down again. Okay, right. So now I've calibrated it, we get to see what it's using while it's calibrated, 8.4 volts. And this is what I wanted to show you. So I'm just going to exit out the menu again. We're going to just get it back in the menu so you get to see there's everything on the screen. It says 8.1 volts there. 8.2, which is, I'm quite happy that that output on there should be 8.4 volts, because if I were to measure it with my other meter, which I feel like I've got to now, right, just hang tight, and we're just going to look at this here. I'm going to put this in, because this meter is pretty accurate. Okay, let's put it on DC. I just want to see actually what's coming out of this now, because I've got to know, I can just stick. I should be able to find a hole in there to stick that, and I should be able to find a hole in there, stick that, and we should be able to see what's on the voltage. So we've got 8.388. That's closer to 8.4 than what that 8.2 on there is saying. So okay, so I'm gonna be quite happy. There's going to be a little bit of, this isn't a, the multimeter costs more than this, okay, and this is doing more than, oh, whatever. It's going to be more accurate from the multimeter, regardless. So let's see now what happens. What we expect to see is that 4.7 watts, nearly 4.8 watts. If it just turns the screen off on here, it's going to stay the same over there. Oh, we don't want to do the follow, do we? So if it turns the screen off here, it's going to stay the same over there. But if it turns off the camera and the transmission, we're going to get a reduced power consumption. So let's turn that off and just exit out of that. And you get to see what's on the screen here. We should still have telemetry, yep. But we just got nothing else. It's still backlit though. So it's going to be using power here still, being backlit. Look at the difference there, like 4.7 watts we had, now we got 1.2, so we can say like over 3.5 watts we use at 8.4 volts. So we got 140 milliamps, 140, flashing between 140 and 150 milliamps. Now let's see what happens to the milliamps when we go down in voltage. So most of you guys will probably know this anyway. Let me just make sure I'm pressing that button correctly. I just want to go down in tens rather than swap hands as well. So we just drop that down. So we're on 1.4, 1.5 milliamps, aren't we? So let's go down to our lowest. That'll be 6.6 volts. There we go, 1.7 milliamps. Let's go back up again, and then we're going to turn the screen back on. Oh, let's drop that down. We don't want to go too high. There'll be some. He'll have some area that you can, you know, it won't. I keep doing that, don't I? Right, let's hold it down for a little bit longer. Just turn it off and hold that down and hold that in. Turn that back on. Ba-bum. Should get our telemetry back. There we go. So we still say 8 volts there rather than 8.4. So now you can see that we've got up to 0.58 amps and we're still drawing 4.8.7 amps watts, because that won't really change because it's still going to draw the same amount of power. It's just going to have a difference between how much amps it draws against the voltage, because it's still going to want to equal out the same power consumption. So let's drop that back down to 6.6 as our lowest voltage. So at 6.6 we're drawing 7.2 amps. Sorry, 0.72 amps. 720, split between 710 and 720 milliamps. But still look, drawing the same power, because of course the power consumption will not change, but as the voltage goes down you're going to need more amps to keep that wattage there, and of course the higher the voltage, the less amps you're going to need. I'll put that back to 8.4. There you go, that's it. That's just what I wanted to show. I was really interested. I was wondering whether it switched off here or whether it switched off here, because I didn't realise it switched off in the first place. But there you go, we find out it switches off here, so it stops the camera feed and the transmission.